Up next, scientist Nassim Haramein joins us live from France as we talk about the universe on Coast to Coast AM. Well, I'm looking forward to tonight. Nassim Haramein has spent most of his life researching the geometry of hyperspace, theoretical physics, cosmology, quantum mechanics, biology, chemistry, as well as anthropology and ancient civilizations. Combining this knowledge with an incredible observation of the behavior of nature, he discovered a specific geometric array that he found to be fundamental to creation and the foundation for his unified field theory. Mr. Haramein founded a not-for-profit organization, the Resonance Project Foundation, where as the director of research he continues exploring unification principles and their implications in our world today. He travels worldwide, specifically the U.S., Canada, talking about his theories. Here he is, full program tonight on Coast to Coast. Nassim, how are you, sir?
Very good. Thank you for having me.
My pleasure. You know, I've had so many people over the last 6 months have been sending me email messages and phone calls wanting to get you on the program, and I finally had to break down because they're right. I'm glad you're here.
Thank you very much. I'm glad they're asking. That means they're interested, and there's certainly a lot of interest out there.
Tell me about yourself, Nassim. How did you get interested in this whole field?
It started very early. I was about 9 or 10 years old, and I had an experience at school that kind of launched me into exploring the nature of reality.
Whatever that reality is, huh?
Right. And basically, it was my first lesson in geometry, and the teacher taught us about dimensions. And he made a dot on the blackboard and said the dot is dimension 0 and it doesn't exist. And as soon as he said that, I already had an issue. Because if I could see the dot, how was it that it didn't exist? And then he put a bunch of dots together, made a line, and said that's dimension 1, and it still doesn't exist because it doesn't enclose volume. And then he put 4 lines together to make a plane and called it 2D, and said it still didn't enclose volume, and so it didn't exist. And then all of a sudden he took 6 of these non-existing planes, put them together into a cube, and said this encloses volume, it's dimension 3, and it's the one that you exist in. And that just didn't make sense to me. And so it kind of started me on this adventure about trying to find a solution to that problem. I didn't know at the time that this axiom was the foundation of most of our physics. I mean, Einstein field equations are written on flat space, and so is quantum theory, and so on. And but I didn't know all these things. I just felt like there was a deeper meaning to dimensions than just axiom based on not a complete picture. And so I was looking into it, and I had this intuition. I was in this bus going back home, and I thought about it, and I escaped my bus in my mind's eye, and I rose above the bus, and I saw the bus becoming a dot, and I rose further, and I saw the Earth becoming a dot, and I rose further, and I saw the solar system becoming a dot, and I rose further, and I saw the galaxy becoming a dot, and I thought, wow, it could be dots all the way up. And then I flew back into the galaxy and into the solar system and back into my bus and opened my eyes and looked at my hand, and I thought, wow, I wonder what's in there. And I, closed my eyes, and in my mind's eye flew into my hand, and I saw the cells that we're made of, and there's millions and millions of them, and billions, and I saw that they looked like dots, and then I flew onto the surface of one cell and looked really, really closely, and I saw millions and millions and billions of little dots we call atoms, and then I flew into the middle of one of those, and I saw a dot in the middle, and I thought, wow, it could be dots all the way down, there was a dot in the middle of the atom, and I imagined there could be dots, dividing that dot and so on. And I opened my eyes, and I was so excited. I was like 9 or 10 years old, and I felt like I had found something very fundamental, very crucial.
You were only that age when you were starting to put this together?
Well, yeah.
That's fantastic.
I found out later that many children had the same problem at school when they were taught that axiom. Actually, Buckminster Fuller had the same issue that he mentioned later on, and turns out that my father had the same issue when he was taught that lesson at school. And, and I just felt like there was a way to solve it. And when I had this vision, this moment of illumination, I came back to my bus and opened my eyes, and I looked at people around me, and I kind of had a feeling that they were like made out of dots, that were made out of dots, that were made out of dots to infinity. And they kind of glue. There was a glow around them almost that I could see, and I was really, really excited. And it started me on this adventure into trying to find a solution to describe our world in this infinite division function, in this fractal division of the space to infinity.
Did you find this that you were alone in this thought, or that there were others that believed the same things?
I at the time certainly I found I was really alone in that thought. And actually, when you have these great insights, typically you want to tell someone, and you know how that goes usually. You get the looks. And so I ran home and I told my mom about it, and I said, Mom, I think they're wrong at school about dimensions. I think the only thing that exists is the dot, and it's the exact contrary axiom, and that the dot is divisible to infinity. And she looked at me and she said, I don't feel infinite right now, and if you answer that at the school test, you're going to fail geometry. And but she had made a very important point, is that if everything was divided in such a way, if everything has infinity in it, how do we get distinction? How do we get finite boundaries? Our world seems to be built on finite boundaries, and I had to think about that, and that took me some 20 years to figure out, because actually that fundamental problem between infinities and finite boundary is the chasm that's dividing our physics today. We have a theory for the big stuff that's called relativistic equations that are famous because Einstein wrote them.
Sure.
And
you remind me of Einstein a little bit.
Thank you.
You're the younger version, of course.
I'm glad. Those equations actually describe the big stuff, the movement of stars and galaxies and the gravitational effects that they have, and planetary orbits and so on. And then we have quantum theory that describe small stuff like the atom and subatomic particles and the way they interact and their fields and all this stuff. But they don't agree. Those two theories don't agree. Einstein's field equations predict continuums towards infinity, towards singularity.
Uh-huh.
And quantum theory predicts finite boundaries, linear functions, quantum numbers, and these don't agree together. And so now we have a theory that describes the big stuff that's made out of small stuff, because all the big stuff is made out of atoms. And the theory that we have for the small stuff doesn't agree with the theory for the big stuff.
And it shouldn't it?
It should, absolutely. Well, you know, Einstein thought it should, and many other scientists thought it should, but it's like almost 100 years ago, people kind of went along with the idea that they could be two theories, and it became the standard that you can't deal with the atomic level with Einstein's field equation, and you can't deal with the large stuff with quantum theory. And thus started this great quest from certain scientists, and certainly Einstein for the rest of his life, to find a theory that would unify the two. And in the case of Einstein, Einstein was clear that there must be some fundamental mechanical function at the source of reality.